Hello everyone, this is Scott Capel. I'm about to do a little tutorial involving this demo drawing of a cuckoo clock. This is something which was created by a student at Sheridan, and I was going over it with them and decided I'd try and make something which I could then broadcast. As you can see, I've done a fair bit of work on this already. I mean, initially we've got, the situation was low angle on, well, it was a grandfather clock actually, and then they wanted the pendulum to swing out. They just wanted to know, yeah, exactly how, what the, let's just put that in there. They wanted to find out what would happen with the perspective as far as like the pendulum swinging out to either side. I pointed out that for one thing you had a grandfather clock, and if there were sides on it and the pendulum was coming out of the bottom of the clock housing like that, you actually couldn't get the pendulum to swing outside. But that's that's just a design thing we can take care of later. So as you can see, I've done some work on this already, and I kind of indicated that their suggestion for the clock, the pendulum ball would not actually be, you can see over here on this side, it's they've tried to turn it into an ellipse. In a situation like this, we've got 1 point perspective, and everything's facing us. The ball of the pendulum, let's just say the disc of the pendulum, would actually just be a perfect circle, and as a result, as it swung through the arc, it would not change shape at all. I've done a bit of planning. I mean, I just created some, I've obviously created the circle, the entire circle of the arc here, which will help around the pivot point of the pendulum's stem, and that gives me the arc that I need to then plan, where the pendulum will swing. As you can see, there is. I'm just going to start this again. As you can see, there's is some perspective on the pendulum disc, but that would happen in such a way that it would show off its thickness. Okay, and the thickness would obviously, be, have to be determined by, essentially it's a very squat cylinder. Now I'm also doing a little bit more work up here just to show the, I guess, the construction of the clock housing. I guess this was about added detail. I felt that their design was a little basic. Now you can see what I've done. I actually am suggesting here, yeah, just some design changes, like extending the eaves of the, should we call it the roof of the clock, with its shingles, just to show it off a bit better. And obviously any lines of or design details that we put in there are going to have to run really technically down to that VP at the bottom, even though those lines I put in there really aren't doing that. Yes, as you can see, like just to use what they already have there as far as the lines of the sides of the clock, I'm extending those up to a point above, and you can see they come together at a VP up there. So everything else which had anything to do with being vertical in that design would then have to go up to that vanishing point. Okay, just doing a bit more, just some doodling, some scribing of the other design details in the clock face. I'm just trying to make it fit in there. Maybe it's inset a little bit, so we'll get a secondary circle, which would show up because of the angle. Okay, so that's the kind of thing that, yeah, there it is. And the rest, of course, would be hidden from view, again, because of the angle. But those are the kind of design details which give the thing a little bit of believability. It's not just like it's more than just a circle pasted on the front of the clock. It's actually, a hole is cut out, in the wood with the clock face mounted up behind there, and of course you'd have all the clock workings. Yeah, kind of getting into the design here. Now there's an interesting thing, a little bit of history here. You see I'm putting a VI for the numbers on the clock face. If you actually look at old clock faces, you know, on church steeples, etc., cathedrals, whatnot, if you have, you know, find a situation perhaps in Europe, you know, where there would be lots of those, you look closely, you'll see that they don't use the Roman numeral VI for 4, or I should say IV. I got that wrong way around. Instead, because from below, if you look up at the clock face, you can get confused between the number 3 and the number 4 because there are 3 strokes. And you'll notice that they'll have used 4 strokes. And that became the Roman numeral for 4 in situations like that. Go check it out. All right, I'm trying to speed this up a little bit. Where are we going? We're just going ahead, describing the rest of the numbers, and just for the fun of it, add a little bit more detail. Now, what are we doing next here? Well, okay, just some alternates. Trying to increase a suggestion to increase the perspective and the angle on this. And if I did that, I would have to be careful because that would alter the shape of the pendulum, I do believe. There you go. You see, I would end up with a clock face, which would be more of an ellipse, which truly that one in the center should be. There's really a perspective taking hold up there. And so we go. Yeah, okay, so there you go. I've adjusted the clock face for perspective. And then just a bit of retro engineering. It's going back and showing how you might arrive at that. Describe a square in perspective. In this perspective situation, it would obviously go up to, here we go, we're trying to find the square. Okay. It's a matter of subdividing the square, creating the reference points around the side of the square, and then, you know, the ellipse, of course, because a circle is really just an ellipse inside a square. So, a circle is a shape inside a square. So an ellipse is merely a shape inside of a square that has been projected in space, and is, as you can see, you know, turning into something which looks like it's in perspective. Another little added thing to this is that there are 2 centers to something like this. There's an optical center, and then there's an actual physical perspective center. You can see the actual long ends of the ellipse. The longest part of the ellipse is actually a little bit wider, at a point in front of the actual geometric center of the ellipse. And this again is something that has been said many times by others. Go look, you know, Loomis points it out, Robertson points it out in all his work. Okay, geometric. It's the true center. Anyway, this is something that you'll have to deal with when you're drawing it, you know, to create something that looks right rather than it absolutely is right. Okay, what else we got here? So, and then doing the same thing with the pendulum disc itself. Okay. All right, and then the stem. And then the stem itself, of course, we have to find the correct perspective, you know, the degree of the ellipse that would actually be happening, you know, as the stem is, you know, intersecting with the disc. And then Now what I've done here is I've simply just made a copy of it, sent it off to the new pose. Now you see that really isn't going to work. I can't actually do that, although I can. I'm trying to do that in order to find what the stem would actually do. But you obviously can see that the perspective of the disc could not go that way. It would have to vanish to the center. Okay, just doing a little bit more detail work up there where the stem is going up through the body of the clock, creating the stem. Okay, actually creating structure now to suggest where the perspective would go for the disc, and actually building the shape up. I must say I've noticed that I have a discrepancy here. I'm taking it to a VP, which I don't think is actually the correct one. It would actually have to go to that same VP, which has been indicated. You can see just below the center position of the pendulum disc, so I may have to go back and adjust. I really should adjust this tutorial. Anyway, there we go. But what's going to happen? Now, that really should just be a perfect circle. However, with perspective, if this is set up in a way that distortion will occur, then you will get a distorted ellipse, which could be aesthetically pleasing. Distortion usually isn't that pleasing, but let's just say it could be aesthetically something that you want to incorporate because of your design style or something like that. Okay, so in other words, you could get it, even though I'm saying that by rights the circle should stay a perfect circle. There can't be situations where the circle would distort and become, well, I would say a bit more of an egg shape. As you can see, I'm trying to find the what is essentially an ellipse inside the projected square, although the angle is such that the degree of that ellipse is quite wide. But we are still dealing with 1-point perspective here. All right. Now, this is just a technical check. So using perspective tools, or rather the tools in Photoshop, the marquee tool and the stroke tool to find a circle. Now I'm actually fitting that circle into my shape, the so-called square, and finding that the technically created ellipse is it's showing up. It's just a check against my drawing. It's showing the discrepancies of my drawing. Okay, so that gives us that. Just working with it to make it fit, and then I'm just copying that over to there. Now by rights, again, as I said, that should be identical. But depending on the perspective situation, as you can see in the lower right-hand corner, the ellipse is not really meeting the so-called square. Yeah, down there. And so that's something that I would have to adjust. Again, this is, if I want to make a distorted perspective situation. All right, and there we go, creating and that's pretty much the end of that demo as far as I took it with the drawing. But there you go. So that's showing perspective situation, somewhat distorted perspective. but following an object as it swings through space, if it were something that had to be animated in a scene, by hand, obviously you could draw it by hand there, but there are, some, let's say, technical aids that, digital drawing affords us to help us, get the shapes we want. All right, thanks very much for watching, and we'll see you soon.